In this unit, we're going to speak about how computers use the network to work together. There are several models that in some cases are called architectures that computers can follow when they collaborate using a network. And in this video, we're going to see the most significant. And we'll also speak a little bit about network operating system concepts and see how they have now been incorporated in modern operating systems. So let's start with the first model of collaboration, that is the central computer with terminals. So this model was developed in the early 1970s when many mainframes developed interactive user interfaces and they operated as time-sharing computers. They would support hundreds of users simultaneously and they would use batch processing to do that. So at first these users logged in with a dumb local terminal connected with serial ports, which soon became remote terminals that used modems to connect to the computers. So in this model, all the computer power is in the central computer, and the remote system acts only as an input-output device, and it's used with mainframes and also supercomputers. So to access as a remote terminal with a personal computer, we would use terminal emulation software. A typical example of this model is, for example, point-of-sale devices that you can find in department stores that are connected to a central computer. So the next model is peer-to-peer networking, and in peer-to-peer networking, users are able to share resources and files located on their computers, and they can access shared resources from others. And this can all be done without the need for a central coordination by a server or some stable host. So in peer-to-peer networks, as the name suggests, all connected computers are equals, they are peers. And they all share the same abilities to use resources available on the networks. So peers can be both suppliers and consumers of resources, and they all together are said to form a peer-to-peer network of nodes. So peer-to-peer networking has been made popular by file sharing systems like Napster. And there we have, for example, an algorithm that is incorporated into the peer-to-peer communications protocol. And these algorithms make sure that load is balanced and that even peers with modest resources can help to share the load. Files in a peer-to-peer architecture are split into small pieces and they are available in every node that is downloading the file. So if a node becomes unavailable, its shared resources remain available as long as other peers that offer it remain online. So ideally, a peer does not need to achieve high availability because other redundant peers can make up for any resource downtime. And as the availability and load capacity of peers change, the protocol just reroutes the requests. Emerging collaborative P2P systems are going now beyond the era of peers doing similar things while sharing resources, but they're actually looking into having diverse peers that can bring in unique resources and capabilities to a virtual community and thereby empowering it to engage in creative tasks beyond those that can be accomplished by individual peers and but can be beneficial to all the peers in the network. In the next model we see is the client-server architecture. There a server provides a function or service to one or many clients. And these clients initiate requests for servers at the server. So client and server architectures allow network administrators to centralize functions and applications in one or more dedicated servers. So the server is the center of the system, giving access to resources and instituting security. And the server's job is just to respond to service requests from clients following the policies that are established by the company. While the client's job is to use the service provided in response in order to perform some task. And the client and the servers are completely independent instances. Servers can be classified by the services they provide. So for example, you have web servers, and web servers serve web pages. A file server serves computer files, and a database server serves database queries and requests. So a server can offer servers sharing one of its resources. Hardware or software or programs or even data. And it can offer these by sharing them and also the processes and the storage devices. So a single computer can actually offer several services at the same time. So one single computer can be a web server, a database server, and also maybe a file server. And it can run these at the same time to serve different data to clients making different kinds of requests. So whether a computer acts as a client, a server, or both, this is determined by the nature of the application that requires the server. So for example, client software can communicate with the server software within the same computer. And then the same computer is the server as well as the client. But it can also be done within separate computers, and communication between servers, such as to synchronize data, for example, is called inter-server or server-to-server communication. The advantages of client-server architecture include, for example, that we have centralized servers that are more stable. We have security policies that are easily implemented in the server. And new technology and hardware can be easily integrated into the system. Then another advantage is that hardware and operating systems can be specialized with the focus on performance, and it's easier to set up and update backups. And another advantage is that servers are able to be accessed remotely from different locations and different types of systems. There's obviously also some disadvantages, and those include that the cost of buying and running a server can be quite high. Another disadvantage is that there's a dependence on having a central location for operation, and this can create bottlenecks and sensible points of failure. Another drawback is that it requires regular maintenance and updates, and also that servers can be more difficult to configure. So in client and server architectures, the computing power, memory and storage requirements of a server must be scaled appropriately to the expected workload. So load balancing and failover systems are often employed to avoid these bottlenecks and minimize the effects of a server failure. So a networking operating system is a terminology that can be used to refer to two rather different concepts. So on the one hand, it can refer to a specialized operating system for a network device, such for example a router, a switch or firewall. But it can also be used to refer to an operating system which is oriented to computer networking, conceived as an extension to early personal computer operating systems that were designed for a single user using a single computer. So this operating system, this networked operating system, allows for shared files, printer access, and amongst multiple computers in a network. And it enables the sharing of data, users, groups, security applications, and other networking functions that we can have. Network operating systems for personal computers have disappeared a long time ago, as the functions that they can offer are now just integrated in all coming operating system. So we can actually say that modern personal operating systems nowadays are network operating systems. So if we look at some naming, there were peer-to-peer operating systems such as Windows for Workgroups, Apple Share or Lantastic. And client-server network operating system we know are, for example, Novel Network or Bay and Vines.